Dear participants, welcome to this session. My name is Emir Köksal. I have been working for Department of Mathematics of 19 Mayıs University, Samsun, Turkey. In this session, we have 6 presentations. The duration of presentation is 10 minutes. The first speaker is Felix Babalola. The title of the talk is Rest Vein Recognition by Fusion of Multiple Handcrafted Methods. Mr. Felix,
Good afternoon, sir.
Good afternoon. Okay,
Nice start.
you can start.
Can you see my screen?
Yes.
Yes, good afternoon again. My name is Felix Babalola. I'll be presenting on the topic risk vein recognition by fusion of multiple handcrafted methods. We have from the Department of Computer Engineering, Eastern Mediterranean University in North Cyprus. So this is the outline of the presentation. We'll briefly introduce the topic, a brief literature review, and the proposed method will be explained, experiments and results will be given, then the conclusion. So this topic is all about a biometric system. And as we know, biometric traits such as face, palm print are used commonly around the world for human authentication. This has given rise to a lot of technology that helps to acquire the features correctly. Uh, Another dimension is the use of hand vein from the wrist, finger, palm, and dorsal fin, which is what we did uh, in this study. So why is wrist vein, for example, good for human identification? Because of the stability, it is stable, and it has automatic spoof detection uh, property. That is, bodies presented to the system for capturing the image must be alive, otherwise the vein will not be visible. So it's also easy to make sure the system is devoid of occlusion, that is, nothing is covering the system when we are carrying it. And then the system is a fast one and also user friendly because it can be made to be contactless when acquiring these images. So in this paper, like I said, we will combine the strength of 3 different feature-based feature descriptors to build a risk-based recognition system. These descriptors are binarized statistical image features, BSRF, 2D Gabor filter, and histogram of oriented gradient, ORG. The experiment is performed on 2 datasets from FYO database and PUT database. So this is the motivation for our work. We from literature we realize that these images are captured using either infrared camera or near infrared LED source cameras. So the first of such database was in 2011, and this is the only or the first restrained database that is publicly available for us. And others have come up, but most of them are not publicly available. Subsequently, also, several studies have proposed different usage of traits and how to extract the inherent unique features in these features, in this trait effectively. Others have also combined risk traits with other traits.
And the channel as well. I've had some like
such as combining dosaphane and risphane, and also combining palm and risphane patterns using Gabo features. And even we use three different patterns, the wrist vein and palm vein and dorsal vein, and combine them together to form a very strong system. But in this study, this is the proposed architecture as seen here. As you see, we combine three different descriptors. So the architecture can be divided into three phases: the pre-processing state, the feature extraction phase, and the combination phase. So I'll start with the pre-processing phase is in two steps. Region of interest cropping. As you see from this image, we have to crop out the parts that are not needed, like the background and other parts of the hand that are not raised have to be cropped out. Then image enhancement using histogram equalization is a very common way of enhancing an image by contrast uh, augmentation. However, with further experiment, we find that of the three methods, only one of them required this step. So we used it only for the 2D Gabo feed. Now we take the three descriptors one by one, starting with BSI. BSI was proposed in 2012 for person identification. The method was motivated by LBP and LPQ. So they work in the same way, only that the features in BSIF were actually gotten from natural images. And there is a bank of features for BSIF, which has 57 different features of different sizes. I will show, for example, here we have this 3 by 3 filter. Apart from the size, there's also the length. So this, for example, is of length 5, 3 by 3 of length 5. And then another example is this 7 by 7 of length 6. This is how the feature will look like. So based on these, there are 57 features. So one of the literature of in 2015 proposed that we use the whole feature bank for a robust system. However, in our own case, we propose that we use just 5 of them. Instead of 57, we should use just 5 of them. So in order to do this, first we have to determine the best depth. Instead of using all the depth, determine one particular depth. So from experiment, we determine that 12 is the best, and then we determine the first 5 using this 12 depth. So this image here shows some of the results we did using different feature sizes from 5 by 5, 7 by 7, 9 by 9, up to 17 by 17. And as you can see from here, clearly we can determine which of them is best. So from there, we determine which of the features to be used, and having decided on the 5 to use, we will get our MBSIF. So MBSIF is defined then as the BSIF feature extraction method using multiple features, specifically 5 features. So these features will be used to extract features from the images, and then the features will be concatenated in feature level fusion. It's a very simple fusion process. Just join the features together. Then the second one is 2D Gabo filter. 2D Gabo filter is very common. So it's also a linear filter based on texture-based linear filter. It analyzes images um, using real part and imaginary part. It's a band-pass spatial filter capable of selecting both spatial frequency and orientation. So yeah, the output of Gabor filtering is an input image in a complex of real and imaginary part. So like I mentioned earlier, before using this filter to extract feature from the image, we use histogram equalization first. Then the third feature descriptor is the histogram of oriented gradient hog. Hog works by counting the occurrence of gradient orientation in localized portion of an image. This is done in two steps. The first step is computing using one-dimensional maps in both the horizontal and vertical directions of a cell. So cells are um, like a mass around a pixel. So neighborhood of each pixel determine this gradient. Then these cells will then be added to form a larger group, and these groups will be normalized and to make the system to make the system robust in terms of to, rotation and shifting of hands, so that when images are rotated, they are still able to be determined as the same. So lastly, we have to add the decision from these three descriptors together. So the decisions first are named as decision 1 for MBSIF, decision 2 for 2D Gabo, and decision 3 for HOG. The, each decision is either correct or incorrect, so true or false. Then weights are assigned to the decisions accordingly. So zero for false, and one for true. However, because MBSIF uses five different filters, and from our experiment, we find it to be the best in all cases. So we assign higher weight to MBSIF. So weight of 2 was given to MBSIF. Now we need to check the data set that we're using. Like I said, we use FYO database and put uh, database. Most importantly, are we say the difference between these data sets. We want to ensure that no overfitting is done during the training phase. So cross-validation is very important. So for FYO dataset, it has two sections. Each section has one sample image. So for training, we use one of the section, that is the first section for training, and then the second section for testing. Then a second experiment is carried out by using the second for training and the first session for testing. Then an average of these two experiments is used um, as the result of the whole system. Similarly, in the put data set, which has three sections with four samples per section, we have three different experiments. So in the first experiment, sections 1 and 2 are used for training, and section 3 for testing. Then it means that the second section experiment, we have section 1 and 3 for training, and section 2 for testing. And we do the same in the third experiment in this way, swapping the sections, so that we have three different experiments with three different results, and the average of this result will be the accuracy of the system. Lastly, we bring up all the results from the experiment. We have the individual methods. The result of the individual methods are given by using all the three uh, descriptors that we use, and also BSIF and MBSIF. As we know, BSIF we're using just one feature, but in MBSIF we use five features. So we compare the result of these two, then multiple methods, that is combining the methods. First, we combine BSI with Gabor. We see that the result is lower when we compare it with, for example, BSI alone. And then adding all, there is a little improvement in the result. So, and then we finally take the proposed method, which gave us a much better result in compared to all the other methods, as you see from the result. So finally, in this study, we introduced a risk-frame recognition method and test the method using two data sets from FYO and PUT databases. Since the methods combine three feature descriptors, the result of the system is compared to the result of the individual feature extraction methods, as we have seen from the table shown before. The result of the proposed architecture proved to be better than when the methods are used individually, and the accuracy are generally better than any of the individual methods in both the dataset, that is FYO dataset and the PUT dataset. So future research will focus on using deep learning methods in similar architecture as shown in this work. Thank you for listening. I'll be ready to answer your questions if there's any.
Thank you very much for your talk. Do you have any question, comment, or remark? Thanks again for your talk.
Thank you.
Okay. Next two talks will be given by Ayat Al-Masri. The title of the first talk is Trajectory Planning Optimization for the Autonomous Three-Wheeled Omnidirectional Mobile Robots. The second talk is Modeling and Optimal Motion Planning for the Omnidirectional Mobile Robot with three orthogonal wheels.
Good afternoon, Emerja. How are you? I am Iyad Al-Masri. Ojan, can you hear me clearly?
Yes, we can hear you.
My sound is clear. Okay. Now I can share my screen, I think. Yes. You want to continue? Yes. Okay, I'll start with this one. Share.
Okay.
Okay, Emerja, I think now my screen is online, I think.
Right.
Okay. Okay, thank you very much. Good afternoon, everyone. Let me first introduce myself. My name is Iyad Al-Masri, and I am a PhD candidate in Electrical and Electronic Engineering Department at Western Mediterranean University. Actually, I am here to present the paper entitled Trajectory Planning Optimization for the Autonomous Three-Wheeled Omnidirectional Mobile Robot. This presentation will be organized to be divided into 4 different sections. The first section will be an introduction and research aims, the proposed method of solving the trajectory planning optimization of the three-wheeled omnidirectional mobile robots will be discussed in section 2. Then simulations and result validation will be presented in the third section. Finally, conclusions and a few final words will be provided in the last section. Okay, moving to the introduction to the research aims. Actually, the trajectory planning optimization identified as the actions that must be taken to generate the optimal path so that it improves the performance of the robot or reduces the consumption of the resources where the restriction system remains maintained. This study aims to develop a method to achieve improvements in the trajectory planning optimization for the omnidirectional wheeled mobile robot with 3 omnidirectional orthogonal wheels. The considered robot actually has full omnidirectional motion proficiency, as it can actually transport instantly in any direction from any configuration. The maneuverability advantage of this robot based on the usage of the orthogonal omnidirectional wheels that achieve active movements in the direction active movement in the direction of the rotor shaft and passive movement on the direction of the motor shaft. The considered orthogonal wheel consists of central wheels carrying a number of inner rollers and larger outer rollers arranged alternately surrounding the circumference of the wheel that can slide freely in the direction of the motor shaft. Actually, here the figure demonstrates the structure and the configuration of the considered robot. Actually, here let's talk about a little bit about the robot geometry. The robot illustrated in this figure is equipped with 3 orthogonal wheels equally organized at 120 degrees on the boundary of the robot. 3 translational velocities, V1 and V2 and V3, are applied to the 3 wheels along the directional D1, D2, and D3 respectively. The positive direction of rotation is considered as the rotation in the counterclockwise direction in this movement. A local reference frame, OL, X sub L, and Y sub L, is defined to be associated with the center of mass of the robot. Actually, the X sub L here is coincident to the axis of rotation of the first wheel. Those are coincident to each other. We actually attach a local reference frame to each wheel. To each wheel, we are attaching a reference frame as X1, Y1, X2, Y2, and X3, Y3, so that X sub I or X sub J axis is coincident to the shaft of each wheel. Moreover, a system of the global reference frame, X sub F and Y sub F and O sub F, is defined in order to observe the motion of the robot so that the X axis of the local reference frame, this one, X sub L and X sub F, are associated with the angle theta, so that we can observe the position of the robot by using actually 3 parameters. The first is actually 2 parameters. Those are the projection of these points on the X sub F and Y sub F, and the angle theta that associate the angle between X sub L and X sub F. Okay, let's move to the equation of motion of this robot. Actually, we have here the kinematic equation that demonstrates the relationship between the velocities of the center of mass and the velocities or the angular velocities of the robot wheels. Here, actually, we have the dynamic equations or the system of motion equation of this robot. Actually, here all the parameters are defined. Actually, here the matrices M, capital M, capital A, and capital Q are represented here. And actually, here the U is the control input vector, where actually U sub I or U1, U2, U3 are the voltage profile applied to the I wheel DC motor. Here we have the state vector. It is just to localize the robot in any time by, as I mentioned before, X, Y, and the angle theta. Here we have M and J are respectively the mass and the moment of inertia of the robot. Here also we have the constant alpha and theta that can be determined by the motor parameters and the geometry of the wheels. And actually, I will talk about this model specifically in the next presentation, because I will talk about the model of this one. Okay, now let's move to the proposed method of this paper. Actually, here in this study, the trajectory planning optimization formalized as an optimal control problem. That the optimal control problem defined as the problem of moving the robot from initial configuration, from like this configuration, from initial configuration to a final configuration with the optimality of the maneuvering time TF. This is the total maneuvering time between the starting point and or starting configuration and ending configuration while the constraint system of motion remains maintained. The optimal control problem is solved by estimating the control input vector required capital U so that the robot can move in the shortest possible time. Actually, here let's talk about the constraint system. Actually, several constraint systems that could be raised due to different reasons. However, we have in robotics field very important two constraints actually have a special importance. The first one is constraint on the acceleration amplitude that xw prime square plus yw prime square, it should be less than alpha maximum. So this is the first constraint. The other one, actually, it is like more important, and it's actually very important, is that the control input of the DC motor of the robot wheels must be less than a specific value. Okay, so the optimal control problem formalized in this scope actually by relaxing the end condition. That is mean only require at the end of the trajectory the actual final position and velocity are close enough to the initially planned ending position and velocity. Actually, this closeness is formalized by E terminal.
Ayat,
Yes,
sorry for
yes.
breaking, but
Yes,
please check the time, okay?
Okay,
Please
okay.
check the time. The
Okay,
duration of presentation is 10 minutes.
okay. Okay, here we have the gamma is the positive weight corresponding to the trade-off between the maneuvering time and the maneuvering time and the terminal error. Okay, now here we have just before going to explain the proposed method specifically. Here, let's talk about, of course, we need a lower and upper bound for the free variable t sub f that should be identified to produce the feasible domain. Actually, the constraints, these constraints, actually, we will use these constraints to to generate the TF lower bound. And the TF upper bound, it could be chosen based on experience of the robot and the workplace. Okay, here the third order polynomials will be used to represent a simple reference trajectory that it could be implemented for the four boundary conditions, two on the position and two regarding the velocity. The terminal error computed by tracking the error along the trajectory. Here we have the error along the trajectory expressed as Z, which is the actual trajectory and the reference trajectory. And the difference between them is actually E of t. This is the error generated along the trajectory. How we can actually demonstrate this, or how we can find this error using the constraint dynamic inversion test method. Actually, the tracking error is accomplished using constraint dynamic inversion based control law with saturation, actually by solving this nonlinear, non-autonomous differential equation. So this equation must be calculated and must be solved each time we are considering the a value of the free variable t sub f. Here actually let's just explain a little bit here the this flowchart. So first, in order to find the optimal trajectory. So actually, we will start with generate an initial solution for the decision variable t sub f randomly in the range specified by the lower and upper bound. Then we can generate a new candidate solution by creating a random factor. Then we can apply the constraints dynamic inversion test method so that the fourth order rank kata use it to solve this one. Then if the t sub f2 is better than t sub f1, so we will accept that this is using the simulated annealing algorithm. So actually using this algorithm, it is possible to accept some non-validated solution because we need to avoid the local finding the local optimal solution or the local solution. So to avoid that, we can accept some bad solution for T of F. Then it is actually just a normal simulated annealing algorithm. Then we can, if the stopping criteria of the inner loop met, so we can decrease the temperature. Then if the stopping criteria of the outer loop met, then we will accept the T of S, T sub F, which is the total maneuvering time. And based on this solution, then we can calculate the vector U, which is the voltage profiles on the of the DC motor of the wheels. Here we are talking about the numerical values of actually of the experiments that we did. Here actually in the table 4, here the starting and termination configuration, here the parameter of the simulated annealing, here is the acceptance error, and here are different parameters of the robot. Actually, here is the result. Actually, here the constraints dynamic inversion test simulated annealing, which is proposed in this article. We run the algorithm 3 times, and this is actually by using the original research. Original research is just they are using with the bisection method actually, and we can see that the results show clearly that there is an improvement concerning the fitness function with an enhancement between 26% to 44%, and it is clearly noticeable that there is a significant decrease in terminal error. Furthermore, it is observable that the optimal final time required for the robot navigation between the initial and final configuration becomes shorter. Here, let me just show you by using our proposed method. Actually, we converge to the optimal solution, whereas the constraints dynamic inversion test with the bisection method is failed to converge to the optimal solution. Here is the tracking error using the original research, and here using our proposed method with constraints dynamic inversion test with the simulated annealing algorithm. So as we can see, it is a difference, like the error at the angle, it's dropped from 0.1 radian, it means like 5 degrees, to less than 0.02 radian. As a conclusion, the present research established a computationally effective optimal trajectory planning method based on the integration of the constraint dynamic inversion test method with the simulated annealing algorithm. It has been shown by experiments that the trajectory generated by applying the proposed algorithm effectively satisfies the constraint system and demonstrates a remarkable improvement in terms of the optimal traveling time required and the terminal error. This is the here the method of the original research of the constraints dynamic inversion path with the bisection method. I'm ready if there is any question.
Thank you very much. Do you have any question, comment or remark? No question. Okay, then you can continue.
Okay, let's continue with the other one. Okay, now I will share with okay, Hisham, so this is the second paper presentation. Okay, so this presentation to discuss the paper entitled Modeling and Optimal Motion Planning for the Omnidirectional Mobile Robot with 3 orthogonal wheels. Actually, this presentation will be organized to be divided into 4 different sections. The first section will be an introduction and research aim, model analysis of the 3-wheeled omnidirectional mobile robot using network model approach method will be discussed in section 2. Motion analysis of the robot using constraint dynamic inversion path simulated annealing method will be discussed in section 3. Conclusions and final words will be provided in the last section. Actually, the research goal of this paper actually to derive a new compact mathematical model for the 3-wheeled omnidirectional robot by using the network model approach method to analyze the mechanical and electrical systems of the robot. The advantage of this method is actually without switching from one method to another, so that the same method can be used in mechanical and electrical systems. Then the hybridized algorithm of constraints dynamic inversion path simulated annealing algorithm has been experienced in collision-free motion planning by incorporation of the path constraints using the VROOM3 diagram. Actually, here the model I explained in the first presentation. Okay, here let's talk about the modeling of the robot. In this model, actually, the robot will be considered as a multi-rigid body system because a network model approach method is based on the multi-rigid body system. We will model the robot as follows. Actually, the platform of the robot will be represented as a rigid body depicted by the symbol R. However, we can consider the rigid body R as a multi-terminal components with 4 ports, representing the connection points of the platform along with the wheels and the mass center of the robot G. In order to set up the vectorial terminals equation of the multi-terminal rigid body R, let's consider its vector terminal graph depicted in the following figure. So here is the vector terminal graph of the robot platform, and it can be seen P1, P2, P3. P1, those are the connection with the wheels, and G is the connection with the mass center of gravity. Since the platform of the robot represented as a multi-terminal rigid body, its kinematic relation is fully determined in terms of the across variable. V sub pi and W sub pi, those actually the representation of the actually linear and angular velocities vectors. Those are vector representations of its torques. The terminal equation that show the kinematic relation that exists between the terminal across variable regarding the vector terminal graph based on the network model approach given as follows. So we will use that to derive the kinematic equation of the robot platform. Here, as you can see here, we have the matrix K sub G Pi represent the kinematic relation between the terminal across variables of the port P sub I and the terminal across variables of the port G expressed as follow, where I is the identity 3 by 3 identity matrices. I here and here. The matrix R sub G Pi is the skew symmetric matrix representation of the vector R sub G Pi, that is the positional vector of the point Pi relative to the reference. This one, this is like P2 is written expressed in terms of the reference frame. This is the vector. Okay, so the across variable V sub G and W sub G at the port G is very clear to be V sub G is the linear velocity x prime, y prime, and W sub G is theta prime. Then by just substitute R sub GP in here and substituted this matrix here actually and substituted this all in this equation, we can get V sub Pi and W sub Pi. Then let's find the explicit form of this equation to be the inverse Jacobian that relate between the velocity of the center of mass and the velocity of the port P1, P2, and P3. Actually, here I am talking about the wheels, how we can represent the wheel using the network model approach. Actually, it is depicted by the symbol W sub I with two ports, A sub I and P sub I, represent the connection points with the platform and the ground. And I will do the same thing with the platform to get to get actually the relationship of between the port PI and the port AI is the same concept as the platform. Then let's now combine the modeling of the wheel and the platform together by the schematic diagram of the robot with three orthogonal wheels illustrated in the following figure. It shows how the robot platform and the wheel are interconnected. Here we have the sources A star till 6 star, A star, 2 star, 3 stars till 6 star describe the terminal conditions in the system, representing the joints between the platform and the wheels and between the wheels and the ground. And here is, we have the system graph of the three-wheeled omnidirectional robot. And based on the system of graph, we can very easily derive the fundamental circuit equations. And based on the fundamental circuit equation, we can, and based on the equation derived in the platform and for the wheel, we can get this equation based on the fundamental circuit equations. And then very easily we can isolate W sub AI. Then it can be written in the expanded form. And here's actually the kinematic relation that relate between the velocities, the angular velocities of the wheels and the velocities of the center of mass of the robot. So by utilizing Moore-Penrose pseudo-inverse, the Jacobian matrix shown in the following equation, and this is the kinematic equation of the robot. The force generated by the IFDC motor The force generated by the ith DC motor attached to the ith robot's wheel with no slip condition. Actually, it is represented in this equation. Okay, where alpha and beta considered to be like this. This is the torque constant, and the r is the radius of the platform. Small r is the radius of the wheel. And this is based on the network model approach. We can get the equation, the dynamic equation of motion using the network model approach. Then, like here, d sub I with respect to f, it could be this is actually the vector that specifies the active drive direction of the I robot's wheel. It is represented here. Just we can very easily substitute it in this equation, and we can write this equation in expanded form to be like this. Then actually here we can substitute the kinematic model that derived in the first step here to get the equation of motion by substituting of the kinematic equation. Then here we can get the equation of motions of the robot. Since the network model approach method is widely used in the engineering field, the establishment of a complete and compact mathematical model for the rigid bodies of the omnidirectional wheel mobile robot using the network model approach method plays an important role in express the complex mathematical model in a way that is more understandable in engineering community. This network modeling of the robot may allow more complex engineering studies from multiple aspects, including stability and durability. Now let's move on the actually second point of this research. It is actually to motion analysis using the constraints dynamic inversion based with the simulated annealing algorithm in the presence of the obstacles. The problem is stated as follow: an omnidirectional mobile robot at starting configuration must reach the terminal configuration while avoiding collisions with static obstacles. The paper presents a new obstacle avoidance motion planning method for an omnidirectional mobile robot. The proposed method targets to incorporate path constraints with the constraints dynamic inversion based method. The obstacle avoidance proposed method is summarized as follow. It is actually we need to the optimal path will be produced between the starting and ending point that ensure the collision free using the Voronoi diagram. So first, we are using the Voronoi diagram to establish some via points that ensure the collide free from the obstacles. Then between each two configuration, we can apply constraints dynamic inversion fast simulated annealing algorithm so that very easily we can establish a trajectory we can establish the optimal trajectory. So the constraints dynamic inversion path method is to be used between every two adjacent via points along the path to compute an optimal trajectory between the points, ending by finding the optimal trajectory between the starting point and the destination that achieve obstacle avoidance. So this is actually the optimal trajectory between the initial and final point. And this is actually the control input voltage profile of the robot. So those voltages must be applied to the wheel DC motor so that the robot can navigate to the ending condition. As a conclusion, the present research established a new obstacle avoidance motion planning method for an omnidirectional mobile robot by proof of incorporation of the path constraints with the constraints dynamic inversion path simulated annealing algorithm. The free collision trajectory has been evaluated satisfactorily in terms of avoiding the obstacles and the smoothness of the trajectory. Furthermore, a new mathematical model aimed to represent the three-wheeled omnidirectional robot using network model approach has been developed in this research in order to express the complex mathematical model of the robot in a way that is more comprehensible in the engineering community. Thank you so much for listening, and I'm ready for any questions.
Thank you very much for your talk. Do you have any
Thank you,
question,
Amir. Thank you so much.
comments, or remark? No question. Thanks again for your talk.
Thank you. Thank you very much.
Next speaker is Mario Malik. The title of the talk is Computational Brain Tumor Detection in MRI Image Using Straightforward Image Processing Techniques and Deep Learning Techniques.
Greetings, everyone. This is Mary Malik. Okay, I will start my presentation by sharing my screen. Please let me know when you can see it. Okay, so Mr. Amir, is my screen visible to you now?
Yes.
Okay. So the topic of my presentation today, my research paper, is a comparison of brain tumor detection in MRI images using straightforward image processing techniques and the deep learning techniques. My co-authors are, first of all, let me introduce myself. I'm from the Department of Software Engineering in Superior College, Lahore. And my co-authors are Dr. Irfan Jaffer, who is the Dean of the Department of Computer Science at the Superior College, and Mr. Mohammed Raza Naqvi, who is also from the Department of Computer Science at Superior College, Lahore. First, let's introduce the topic of my research paper. Basically, my research paper is about brain tumor detection. And the brain tumor is a small mass that is formed inside the human brain, which leads to malfunctioning of the brain. Sometimes the tumor is benign and sometimes it is malignant. If in the case it is malignant, then it can cause severe life-threatening life threats to the patient. And this is why the early detection of such a disease is very critical. And many algorithms, many methodologies, many different ways are used to find out this tumor and the nature of the tumor as soon as possible to save life of the patients. As we know, it's a brutal illness that can trigger severe pain for the patients, and it can also cause severe conditions. This is why we use different efficient methods for detecting tumor in the MRI scans. There is another way, and most commonly there are two ways in which brain tumor can be detected from images. The first one is the CT scans, which is a computerized tomography scan, and they're formed by getting the picture of the infected area from different angles through rotated images, and they are mostly X-ray images, and then they are processed over a computer software to form CT scan. Another way of detecting brain tumor is through MRI scans, and they are three-dimensional anatomical images, and they are also obtained through medical imaging techniques. So mainly the tumor is detected through medical images, which we obtain. The purpose of this study is to analyze the competency or the effectiveness or the efficiency of straightforward image processing techniques that involve mainly of image segmentation techniques and edge detection techniques to find out whether whether the MRI scan is of a patient that has the disease or not. So it means we are detecting the brain tumor from straightforward images, and then we are going to compare the results with the deep learning techniques that are used to detect brain tumor in MRI images. To examine the brain tumor detection, we are going to apply or incorporate the straightforward image processing techniques in our methodology. And then we are going to compare the results with the state of the art or the previously published research papers that are working on the same problem, but with deep learning techniques. After that, we're going to determine whether the method of straightforward image processing techniques is more efficient or the deep learning techniques, which is now more commonly being used, which one is better. Lastly, we're going to prefer or suggest some of the points that future researchers can take for solving similar problems. In the literature review, we have studied several past papers, several past research papers and publications which were significant in solving the similar problems. Some of the examples are, I can give you the example. For example, we have a paper that was published in 2020. It was by Eliza et al. And it proposed a simple or the straightforward image processing technique for detection of the neoplasm, which is the tumor inside the brain, human brain using MRI scans. The approach that the research used, it was simply first they have to apply pre-processing phase and then edge detection. And then they used segmentation for finding out the tumor, for detecting the tumor. Next, M. Zawish et al. They published their paper in 2018 and they presented a report by applying image segmentation method, and they constructed based on the total radiation method for precise segmentation of neoplasm in the brain from the data collection of MRI scans. The methodology that we are going to implement in this paper, in this research paper, is divided into two parts. The first one is the detection of the tumor using simple straightforward images on the dataset that we have obtained from a public repository. Then the results and the accuracy of the simple or the straightforward image processing technique is compared with the state-of-the-art deep learning techniques that are incorporated by previous researchers for brain tumor detection in MRI images. For applying the straightforward image processing techniques for detection of brain tumor, we have worked on the following steps. First, the data was acquired, and we obtained a data set of 3,762 images that was obtained from Kaggle, which is a public repository, which is also used in many other research publications for obtaining and for experimenting on the data sets for educational purposes. And these MRI images were then preprocessed, and then we removed noise from these images because some of the images contained noise, and we applied filtering approaches to clean the data. After that, we applied the edge detection operation for detection of the boundaries in the image, and then segmentation and morphological operations were applied for finding out the desired detail from the input, which is the tumor section. After that, we incorporated the comparison of results from the state-of-the-art deep learning techniques, and then we determined which technique was better. In the results that we have found by applying simple straightforward image processing techniques included the steps of pre-processing. And in pre-processing, we used contrast enhancement, and then we converted the images from RGB images to grayscale images to get a standard format. After that, we applied filtering approaches to remove the noise from from the images, and they are removed by denoising methods. And the samples were also analyzed. The high contrast images were also obtained because in some of the images, the contrast was very low. After that, edge detection was applied, and then we applied Sobel operation and then Canny operation to find out the edges. And lastly, the segmentation was applied for highlighting or for finding out the section or the region boundary where Based on thresholding, we found out the segmented area, which was infected area, as you can see in the image as well. So we found out that the accuracy of deep learning models was more than the simple, straightforward image processing techniques. And also we found out that the deep learning methods for detecting the brain tumor of binary classification of brain tumor was significantly more like significant or better than the straightforward image processing techniques. After that, we found out that the sigmoid function is futile or useless for the detection of multi-class classification if we have tumor of different types. That cannot be done through the sigmoid function. Hence, the incorporation of a system of convolution neural networks with modified softmax loss function and regularization is more useful in enhancing the accuracy. Although straightforward image processing techniques give decent results, the accuracy of deep learning model for the detection of brain tumor is much better and more accurate. The research is limited because we have chosen a sample size which is limited to around less than 4,000 images. So the sample size is very low or less. So we can, in the future, this methodology can also be applied on larger data sets, and that is recommended. And also this research compares the results of detection of MRI images for brain tumor detection only. But this technique can also be applied on other diseases like cancer or any other disease that can be detected from MRI images. Thank you very much. If you have any question, you can ask, please.
Thank you very much for your talk. Any question, comments, or remark? No question. Thanks again for your talk. Next speaker is Martin Kalaev. The title of his talk is Comparative Analysis of Activation Functions Used in the Hidden Layers of Deep Neural Networks.
Good morning. Good afternoon. So, may I begin? Oh, do you hear me?
Yes.
Okay, let's begin. So, my presentation is comparative analysis of activation function used in hidden layers of deep neural networks. Let's talk about the abstract. The development of neural networks is significant, and current work is my current work is to compare it to the three very popular function, which is ReLU, sigmoid, and time function, and how they interact with each other, and can one function do the work of another. And yes, this is the focus of the research. Motivation. We may say that neural networks have a long history. The very first mathematical roots of the neural networks are 50 years ago, but the real technology that use a very big neural networks with hundreds of nodes is something very new and something that needs heavy lifting like data mining and burning of CPUs to turn theory into the practice, and this is the focus of the paper, how we take existing theory into a practical solution by black boxing testing of the activation functions. Yes, the text explanation. What we do is, first of all, we create really massive neural networks. extremely massive, to be honest. You may see that one of the biggest layers have 100 of nodes, and 6 layers. This is a really big neural network that we're using here.
Martin,
Oh,
sorry for breaking. Please make full screen.
sorry?
Make the slide full screen. We only just see some parts of the slides. We cannot see.
Oh, sorry.
Make it full screen, okay?
Is it better now? Yes, no? Do I fix it? Is it full screen now? So okay,
Now better, but you can press a button at the bottom of the PowerPoint to make full screen.
oh, I'm sorry.
Anyways, it's okay.
I'm sorry. I'm sorry. Let's move on. The text explanation. What we're doing is make a really huge neural networks, and we train it. And the next thing, we keep the values of the trained basis and the weights for every tensor. And what we do, we exchange the activation function in the largest layer with a different kind of activation function. And we're checking out if the neural networks keep the properties, or are they changing, or what happens. This is the test we're doing. So first thing we need to keep in mind is when we're using oversized neural networks, this is stunning the use of the neural networks. It makes it extremely difficult for neural networks to be trained. Furthermore, we conducted nearly 1 test to get results that are useful, and the reward activation function was the best function because it was easier to be trained. Second function was Zimoid, and the third function that was the worst function in performance was time function. But why we're using oversized neural networks? Because every single anomaly we can see when we are using oversized neural networks is exaggerated, and we can visually represent it, see it, and compare it. And when you use normal neural networks with normal size, these anomalies are extremely hard to be detected, but with extreme oversized neural network, it's way easier. Yes. Pros and cons. First of all, what is reward function? It's a simple function, most widely used function. It's a fast function. What are the cons of this function? It may cause something that's called dead neurons. But dead neurons in neural network is simply put, the sum node of the neural networks return only zero value, no matter what is the input. This is the reward function. Second is Zimoid function. Zimoid function is a function that doesn't return zero, that can return values between 1 and 0. And what is the cons? You can use this function for regression types, like the previous colleague said, that you need functions like this when you decide when you try to use neural networks for regression problems. This is the Zimoid function, and the time function. It's a hyperbolous function. It's very similar to Zimoid function. But these functions return values between -1 to 1. It have similar pros and cons like Zimoid function. This is how all the function works. How all the function looks. I'm sorry, the reward function, like you can see, values and you can be 0, 0.1, etc. The time function and the softmax function. Softmax function we're using for the function in our output leg, last leg, because of course you need to use softmax function for your last leg of the neural networks. So the first results of the ReLU results in famous dead neurons in using a ReLU function. If you get a dead neuron in your neural networks, the whole neural networks will die. But since we are using an extreme version of the neural networks with hundreds of nodes in just one leg, we can have works close to each others, and the neural networks will still work because the neighbor nodes can compensate and do the job of the huge cluster for dead neurons. Yes. The second is Zygmunt results, and this answers the questions: can Zygmunt results be close to the ReLU results, or can we take neural networks that is trained with ReLU and we just switch the ReLU with Zygmunt and keep the same results? And the answer is yes. Yes, in the very specific case. If the ReLU have a very small clusters with dead neurons, the ReLU and Zygmunt function can be exchanged, and the neural networks will keep all the properties and all the memories we trained in these neural networks. However, if we have an extreme case of a huge cluster with just dead neurons, the Zygmunt function cannot replace the ReLU function. Yes. Second, and this is also the very interesting, can hyperbolot activation function replace the ReLU in already trained? And what we find out is that in very rare cases, time function can replace the ReLU function. But what was way more interesting is that time function replacing ReLU function in already trained neural networks. This is very interesting. It shows the hidden bias of the whole neural networks into the certain output. What I mean is, if you take neural networks that is trained and you replace this layer that have ReLU with time function, the whole neural networks will lock in one very specific output. It can be the first class you try to recognize, or the second class you try to recognize, and this is why, and this is because the time function in place of ReLU function create a noise into this layer that exchange, and this noise activates the very hidden bias of the whole neural networks. And this is a very interesting and useful things, because if you have very huge neural networks, you can just replace in this layer with time function, and you can find the hidden bias of the whole neural network. So yes, this is the conclusion. We find out that one in already trained neural networks, we can exchange the activation function of the one leg, and it will keep the properties of the whole leg. We found out that Zygmunt function also can show if the leg have a lot of dead neurons, and we can work around this problem. And we found out that hyperbolot activation function can show the hidden biases of the whole neural networks. Contacts. This is my email with some some of you have questions. And the other things, this is the repository of the neural networks that we work. You can download it, my project, and use it in your research if you find my work interesting. This is my GitHub address repository. And thank you for your attention.
Thank you very much for your talk. Any question, comments, or remark? No question. Thanks again.
Thank you.
Now, title of the last presentation of this session is a simulation-based analysis for a transfer guidance for highly automated driving function. Name of the speaker is Marzana Katun.
So hi, I am sharing my again. Can you see my screen?
Yes.
Okay. So good morning or good afternoon, everyone. First of all, I would like to thank to the Hora conference for giving me the opportunity to present my research results. I'm a PhD student from Camden University of Applied Science and working in a research project under the Institute of Fire Assistant and Finance Mobility, EFN. For today's presentation, I have separated the topic into three main sections. First, I will give short introduction about automated driving and highly automated driving systems and its function like lateral and longitudinal behavior. Second, I will describe the transverse guidance in scenario-based simulation in terms of modeling the scenarios. And finally, I will provide the simulation summary result and conclude my presentation. So highly automated driving systems considered several layers from level 0 to level 5 according to SAE standard. And level 0 to level 2 are considered vehicle functions with some assistance system, for example, parking assist system. Level 3 is considered as conditional automated, which means a vehicle can drive for a longer period of time without any support from driver or human. And level 4 are highly automated driving function, which is an upgraded version for level 3, and level 5 is the fully automated driving system. So transverse guidance assistance system could be used for a highly automated driving function, which means level 3 to higher, and that's the area where I am focusing on. For analysis, the vehicle function scenario-based analysis has been performed. And for this, simulation-based analysis is essential with respect to a use case scenario that I will present. So as a transverse guidance assist function, the main behavior I'm focusing on is lateral and longitudinal function, and this is used or considered in a use case scenario as mentioned in the right side of the slide. So we take a use case scenario in highway, and Ego car, which is our observed vehicle, and Ego car is performing the lane change from right to left and then staying in the left lane and then again change to the previous lane. Here in this slide, we just presented our decision tree for compiling the lateral and longitudinal function by using two main assist function. One is lane keeping assist system and another is adaptive cruise control. So what the two are doing is entire lane change scenario could be performed by using those two systems. To optimize that which control strategy for transverse guidance as a system we could use, we did a short investigation on control strategy. So for our aspect, we used decoupled control and coupled control, and we try to simulate with our use case scenario and realize that for our lane change scenario, couple controlled is more stable, and for further investigation, we considered path following control system as a couple control for our use case scenario simulation. So as I mentioned, for that our use case scenario is lane change maneuver, and to explain and observe the entire scenario, we divided the scenario into three sections or three phases, and these three phases are not new. Author Fulton already demonstrate in a different aspect where we can divided our lane change scenario into three phases, and we just considered that for our investigation. So as a part of phase one, we're considering changing lane from right to left, and we modeled our scenario in MATLAB, considering the proper road width, and we use the vehicle velocity and the distance between the leading vehicle with a relative parameter, and also basic safe distance parameter with other vehicles. As a second phase, we considered that our lane change has been performed, and now we stayed in the left lane and find a place to come back to the previous lane. And on that scenario, we didn't consider any lateral maneuver for the Ego vehicle. And some basic parameter has always been considered, like the length of the vehicle, velocity, and distance in between the vehicles with other vehicle as well. The light colored vehicles are considered as road traffic, and all of the Ego vehicles are considered as our observed vehicle. As a third phase, we considered that at the specific time period T20 is T1, T2 plus T3. So at the last phase, we Ego vehicle can decide to perform the lane change maneuver. And this is considered to be the last phase of the lane change maneuver. Here I always mention logical scenario because this velocity can be changed, the Ego velocity can be changed within a range. So we are not using a specific concrete scenario. We are using from 100 to 140. It's already considered in my observation now, and try to find different tool that I can use it for better result and less time, or which fits for modeling a good amount or set of scenarios. Here I sum up the simulation result, and at this case where in this image, I'm only showing the longitudinal changes of the ego vehicle with three different phases. Phase 1 is the first lane change, and phase 2 didn't perform, so there was no higher peak in the acceleration, we didn't do normally. And then second is finding the last lane change where the ego car is accelerated as a longitudinal distance. The performance for lateral control, the lateral deviation, relative view angle, and steering angle has been considered only. Here we are showing only for phase 1, and we can see that high peak has been happening in lateral because that's the phase when we change from left lane to the right lane. And steering is also we considered around 5 degrees, 5 to 6. This is only showing the same approach as for phase 1. We are considering now for phase 2 and 3 for the lateral control system. As I mentioned, that why we need this investigation, why we need to do from basic start from using a use case scenario. The reason is for autonomous vehicle, humans are always not always responsible for the function, which is nowadays quite common up to level 2 vehicle. And our focus is that for level 3 and higher, vehicle itself can take its own decision when and how to drive. For this motivation, we started. We take this result from basic MATLAB simulation result and try to implement this in tools like CarMaker. That you can see, I'm using this same scenario and varying the ego vehicles parameter and observing whether there is a chance to have a collision or not. And this use case scenario helped us also to realize how the vehicle behavior in general affect when two different systems are working together. For example, if adaptive cross control, for example ACC, which only considered the longitudinal behavior, is working not exactly same when we wanted to incorporate the lane keeping assist system together. So that's the investigation we have done in this research topic, that how we can combine several this supporting assist system that could lead us to an acceptable range to achieve level 3 functionality. As a further work, we are still working with different complex scenario, and that could be highway with construction site or heavy traffic. And we are planning to incorporate even working with two tools combined, like MATLAB with CarMaker, to get the final simulation and to observe that how the parameter will be changed and how we can omit collision in transverse guidance assist system. I would say that's all from my side, and I'm open for any question if there is.
Thank you very much for your question. Sorry, presentation. Do you have any questions?
Good afternoon. I'm Algirdas Dobrovolskis from Kaunas University of Technology in Lithuania, and I would like to present my paper, Hybrid Explainable Smart House Control System. So in this presentation, there will be introduction section, method of my paper, how it was trained, and I will present the results, conclusion, and then we can have a discussion. So to introduce this subject, that explainable artificial intelligence has been on rising research side, especially with DARPA, defense agency in USA, who are researching explainable artificial intelligence for military applications. Also, there are other different studies because there was a lack of explanation to humans, so they could trust artificial intelligent partners. And one of those researches where trust is needed is house control. So we have a smart house laboratory in our real-time research center, where we are measuring some parameters such as temperature, humidity, and light settings in the room. And those parameters are also recorded into the database. So the proposed method was to teach the algorithms using machine learning systems with those sensor inputs, so that the system could control heating, lighting, and ventilation according to user habits. And also we have to explain the made decisions for the user using fuzzy logic explanation interface to have user verbal explanation. So there were two different machine learning algorithms used. First one is ML.NET, which gets all the data, so it's easy to train. And then we use software decoder to control heating, light, and ventilation separately. The second was classical support vector machines. They are binary classification algorithms. So for each of the control parameter, we had to create different support vector machine. So the first one's for heating, second for light, and third for ventilation. And then we compared the trainer accuracy for machine learning.NET framework, and best solution was fast-tree regression algorithm with 99% accuracy. And alternatively, for support vector machines, the accuracy was also 99%, as you can see in the graph, with small deviation between controlled variables. Also, the trained algorithms were tested with separate test data to measure the prediction loss. And as you can see, the prediction loss didn't exceed the thousands of parts of prediction loss. So we can say that user habits were predicted correctly. And the next step was using fuzzy rule set with parameters none, small, medium, and large to define machine learning algorithm selections for the user. And there we can see the results which were provided for the user with verbal explanations. For example, the light was turned on because it was very dark, and heating was turned on because it was very cold, or the ventilation was turned on because air was humid. And to summarize, both machine learning methods were accurate at predicting control value, but since the support vector machine algorithms has to be split for each control method. If we increase control parameters, it could be very difficult for the configuration to provide those separate data. So using ML.NET framework method is recommended. And we also plan to train this algorithm with different users to provide machine learning control for every room in the laboratory. Thank you for your attention. Maybe you have any questions.
Thank you very much for your talk. Do you have any question? Comments? Remark? No question. Thanks again for your
Thank you.
presentation. Thank you very much for your participation to this session and this international conference. I hope have a great success in your academic career and wishing to meet in other international conference.